Hi guys, good evening everyone. Good evening guys. How are you all? I hope everyone is doing well. So today we are going to talk about one of the really important topic of electrochemistry, that is Nernst equation. For sure you can expect one or two numericals from this topic guys. So yes, we'll be learning about this topic, but before starting this topic, let me just little bit introduce myself to all of you guys, those who are new in the session, so that they'll be knowing about me. So I am Manisha Rani, your chemistry educator at Unacademy, and I have enriched 5 years of experience at reputed institutes for more than 5 years. I have done my masters from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, CSIR NET and GATE. I have given best ranks through my students, and I have given over 1500 selections in JEE Mains Advanced NEET, and I'm a plus verified tutor guys. Now, let me tell you about the classes information where you can get. So you can get the classes information on our Telegram channel. How you can join it guys, you can just scan the barcode which is there on the screen, or what you can do guys, you can use it with the help of link also, or you can check with the campfire as well. So this is the scan code, this is the barcode which you can scan, and you can join the Telegram group. Now talking about our special classes, which are the absolutely free classes on, yes, on our Unacademy platform. So like the way the classes are there on YouTube platform, the same way it is there on the Unacademy platform as well. So in these special classes guys, what you have to know, there are many features for it. First of all, you can learn from your favorite educators for free. You can engage with the educators via polls, and you can clear your doubts in the live special classes. So you can let your favorite educator know that these are all topics you are facing difficulty. So your educator can, yes, can schedule or can prepare, like can make one or other classes, like depending upon how many classes it is going to take for that topic, is going to take that for topic. So it can be, yes, it can be scheduled, and we all can discuss that topic, and you can, yes, you can clear all of it out. So this is one of a good thing. Now talking about the special class timetable, so all I'm showing you all the classes which are already are completed, yes, in the July month, and in August month we'll be keeping some other topics, and I'll be very soon confirming those topics from you guys. So talking about 19 July we discussed about hyperconjugation and aromaticity. On 26 July we discussed about geometrical isomerism, and 28 July we discussed about optical isomerism. So if any of you wanted to have a clarity regarding these topics, because they are really important for your organic chemistry, what you can do, you can go and check out, yes, these classes, and you will get the complete clarity about these topics. Now let's just understand about our Unacademy Plus course classes. So Unacademy subscription has many features guys. Out of that, one of it is you can learn live from the comfort of your home. You will be getting unlimited access to all the courses. You will be learning from the top educators of India. There will be a regular doubt clearing sessions, and we will be doing the exhaustive coverage of syllabus guys. Yes, we'll be doing exhaustive coverage of syllabus. There will be a complete mentorship and guidance throughout. You will be getting all the study material in the PDF format. Yes, there will be the practice tests assigned. Also there will be the live test series guys, by which you can get to know about, yes, your progress, and even though teachers also can get to know about your progress, and they can help you to score better, and to yes, clear all your doubts in the concept. So that can be done. Now talking about, depending upon your okay, good evening Abhishek. No problem, you can check the recording of that session, you can just check it, and yes, if you have any of the difficulties in the chemistry, that also you can let me know in any of the session. So you can first go through that video, and like the previous session, and you can let me know if you get anywhere any doubt. Now Unacademy subscription features, it has like I have already discussed with you, so they are so good. And Unacademy is celebrating the achievers of ISC Class 10. They have achieved a really good score, and we are expecting a good score from, yes, from you all as well. I'm good, Abhishek. What about you? Okay, that's great, Abhishek. Now, let me tell you a very important thing, guys. That, yes, a very important thing, that our offer, which can get you around 41% off, is extended till 31st July till 12 p.m. And what you have to know, you can avail the unlock offer and have a free subscription also up to 6 months. Okay, very good. So what we can understand here, if you enroll for 24 months plus course classes, yes, the actual price is around 44,000, but you have to just pay 26,450. And yes, what you can relate, you will be getting around 41% off. So this is actually very good. Yes, Abhishek, like ICSE board is little more application based, so that's what we can relate. So there is not much difference. It's like 19-20 difference, or maximum you can relate 18-20. There are more application based concepts, or like concepts as in for 11th and 12th the syllabus is absolutely same, right? There is no difference, but only thing is when you will check the ICSE or ISC book, there will be more little detail of the topics in comparison to the CBSE. Very good. Now talking about the upcoming batches for our class 11 and class 12, guys. So for class 12, the batch which is going to start is the Achievers batch, which will be starting from, yes, which will be starting from the 4th August. Yes, who will be taking chemistry classes over there? I'll be taking the chemistry classes, guys. Biology classes will be taken by Lakshya Gera sir. Physics classes will be taken by Mohana Thara ma'am, and maths classes will be taken by Rahul Mohanani sir. Same are there for the ISC class 11 also, but the batch name is from Mastra. Same teacher are going to take the classes for all of you, and we are going to do the exhaustive coverage of syllabus for you guys. And yes, let's just start about the Nernst equation topic without wasting the time. What is that? Nernst equation. So in the previous class also I discussed with all of you that what is Nernst equation. Nernst equation is nothing but it is the equation which gives us the relationship between electrode potential and standard electrode potential. What is Nernst equation, guys? Hi Suman, good evening. Yes, so what is Nernst equation, guys? It is the, yes, it is the relationship between, it is the relationship between electrode potential and standard electrode potential. It is the relationship between electrode potential and standard electrode potential. So you guys must be knowing what is electrode potential. Let me just quickly tell. Electrode potential is nothing but it is the tendency of an electrode to either lose or gain electron. So if an electrode loses an electron, we call oxidation potential for it. If an electrode gains an electron, we call reduction potential for it. And the electrode where oxidation takes place, yes, that we call it as anode, and the electrode where reduction takes place, we call it as cathode. Very good. Now what we can understand, we understood what is electrode potential. Now what is standard electrode potential? Standard electrode potential is when you calculate or when you measure the electrode potential at standard condition, means standard temperature and pressure. If you calculate, you can call it as standard electrode potential. Now how we can relate the relationship between E and E naught? So out by lot of experiments, results, conclusions and derivation, we got the equation which is E is equal to E naught minus RT upon NF ln concentration of metal divided by concentration of metal ion. So what are the terms involved here? Let's just discuss about it. So what is E over here, guys? E is the electrode potential. Electrode potential means, I told you what is that? The tendency of an electrode to either lose or gain electron. So if it loses electron, we'll be defining oxidation potential, or we'll be calling it as anode, right? If it will be gaining electron, we'll be calling it as reduction potential, or we'll be calling it as like it is occurring at cathode. Now E is electrode potential, E naught is standard electrode potential, guys. Now what is R here? Yes, R is universal gas constant which has several values, but here in this we generally use the value which has joules unit. So we can relate R is nothing but universal gas constant. And what is the value for it? It is 8.314. What is that? 8.314 joule per Kelvin per mole. That is the unit for R. Then what is T in R? Yes, what is T in our formula? So if we see the formula again, what we can see here, we have E electrode potential, E naught standard electrode potential, R is universal gas constant, T is temperature. Very good. What is N, guys? N is the, yes, N is equal to number of electrons involved. Yes, N is what? Number of electrons involved in the electrochemical reaction, because when electrochemical reaction will take place, it will involve the loss and gain of electron. So how many electrons are actually getting, yes, getting removed or gained by some atom, so that we can relate as a number of electrons involved. So N is number of electrons involved in a electrochemical reaction. Very good. Now what is F, guys? F is Faraday's constant. What is F, guys? F is Faraday's constant. Very good, guys. So F is Faraday's constant. What is the value for it? That is 96500 coulombs. And what is Faraday? It is the charge carried by 1 mole of electron. So what is that? Charge possessed by 1 mole of an electrons. So that is your F. We understood what is F. F is Faraday's constant. What is Ln, guys? Yes, anyone knows? Ln is, guys, natural log. Ln is natural log, which means its base is exponential. Its base is E. So it is natural log. What is M, guys? M is the concentration of metal. M is what? The concentration of metal which is in solid state. So metal concentration. And obviously if metal in solid, yes, for solids the concentration is considered as 1. So metal is solid, so that's why its concentration is considered as 1. Like what we consider the concentration of metal as 1. Very good. Other than that, what you can relate, what is Mn positive, guys? Mn positive is nothing but given concentration of metal ion. This is a metal, solid metal. Like you can relate, this is sodium and this is sodium ion, Na plus. So this is given concentration of metal ion. So what we got to know, we don't have to learn first of all the derivation of this equation which is here. So this is a basic equation. We'll be doing one small derivation over here by which we can get the cell potential, because here we are using the electrode potential. Now this electrode potential, what you can understand, yes, this electrode potential, how it is related with the standard electrode potential, that's what we have got to know. So electrode potential is related with standard electrode potential in this manner. We also understood what are the terms involved in this formula, so that's what we have understood. Now let's just understand, if we got to know that concentration of metal M is 1, so can I modify the equation? E is equal to E naught minus RT upon NF ln 1 upon concentration of metal ion. So we can write like this, yes, because concentration of metals, they are generally found in solid state except one metal, guys. Can anyone tell which metal is there which is found in liquid state? Yes, who and all can answer it? Tell me, guys. Everyone, Suman, Abhishek, all of you guys, tell me what is the metal which exists in liquid state. Yes, everyone. Tell me, guys. So only there is one metal which exists in liquid state, which is mercury. Other than that, most of the metals, they exist in. Very good. So what we can relate here, we have only one. Yes, metal which exist in liquid state. Other than that, most of them they exist in the solid state, and that's why for most of the metals this is going to be valid, that we can understand. Now this we are mentioning electrode potential. Now tell me guys, electrodes are of how many types? So electrodes are of two types, right? So electrodes are of two types, one is anode, another is cathode. So for both the electrodes, can we define it? So we can write the anode, like EA means electrode potential at anode, we can write it as E naught A minus, yes, minus what I can write, RT by NF, yes, Ln 1 upon Mn positive. Now tell me guys, other metals are solid state, very good. So what you can relate over here, that how we can relate Ln with the log. So remember that guys, Ln is equal to 2.303 log. Ln means the one which has a base E, while log is the one which has a base 10. Correct. So if, remember, we never calculate natural log because it is really difficult to get the, yes, exactly, Abhishek. So what we can relate, the natural log, yes, the natural log, we cannot solve it, we cannot solve the equations with the help of it, so we have to convert it into log whose base is 10. So if I'll be converting it, so you know that Ln is equal to 2.303 log, what I can relate is that I can write EA is equal to E naught A minus, so instead of Ln I can write 2.303 log. So this 2.303 is a constant, so I can keep it before. So 2.303 RT NF log 1 upon Mn positive. So this I can consider as equation 1. Equation 1, what I considered, the one in which I am talking about, it is the electrode potential at anode, right? So at anode we'll be talking about, so the anode's electrode potential we can relate with the standard electrode potential like this. Same way can I write for the cathode? Yes guys, so for cathode we can write it will be equal to E naught C minus 2.303 RT by NF log. So here it was anode, so and concentration of anode, but here it is cathode, so it will be concentration of cathode. So this is your equation 2. Correct guys. So equation 1 I consider the anode. For anode how I can write the relationship, for cathode how I can write, that also I have written. Now what we can relate, we have to do the next step is subtracting equation 1 from equation 2, because you know that E cell is E cathode minus E anode. So subtracting equation 1 from equation 2. So what is equation 1 guys? Tell me. Equation 1 is E anode, equation 2 is E cathode. So what I'll be doing, I'll be subtracting E cathode minus E anode. So what it will become guys? Yes, it will become E naught cathode minus E naught anode. Can I write like this? Yes. If I'll be subtracting it, so you can relate full thing I will write here, this and then this. So you can relate in both of the things. This 2.303 RT by NF is common, so I can just simplify that. So if you want, we can write like completely also, and then we can do it so that you will get a better clarity. So E naught cathode minus, what I'll be writing, minus 2.303 RT by NF log 1 upon Mn positive cathode minus E naught anode minus 2.303 RT by NF log concentration of anode. Very good. So this is here which I am subtracting. So what you can relate over here guys, it's very simple. Here this whole thing is common. This whole thing is common, so I can just write the equation on the basis of that. So EC minus EA, what I can write EC minus EA, which is E cell. Remember what is E cell guys? Cell potential, it is the difference of potential at cathode, right, and anode. So we can relate that. So E cell is equal to E naught cathode minus E naught anode, I can write. Yes, then I can write minus 2.303 RT by NF as common thing, and what I can write 1 upon concentration of cathode minus 1 upon concentration of anode. Everyone understood this equation? Tell me. This I'm calling equation 3. Anyone is having any doubt? It's so simple. We just simplified the equation. We are trying to get the cell potential from your electrode potential. Exactly. E, what you can relate? E, yes, E cathode. E cell is E cathode minus E anode. So that we can relate as the E cell. Now, what we can understand here, everyone, that E naught cathode minus E naught anode, you can write it as E naught cell. Yes, everyone. So this I can write it as E naught cell. So I can write further the equation as E cell is equal to E naught cell minus, yes, 2.303 RT by NF log. Now what you can relate here, log, I was having a common log like 2.303 RT by NF log was also there, no? So this I skipped. So 2.303 RT by NF log is also common in both the things it is there. So log 1 upon Mn concentration of ion cathode minus concentration of ion anode. Now all of you know some of the identities related to log. Tell me. Yes, everyone, how many of you know the identities? So I was having 1 upon concentration of cathode minus concentration of anode. Now remember that, guys, there are some identity as a note you can write it. What are those? That log A minus log B is equal to log A by B. This is one of the identity which everyone should know. Then log A plus log B is equal to log A into B. Yes, remember, whenever you have log A to the power M, you can always write it as M log A. Yes, along with these three identities, you should know some values also of log, guys. By that, you will be able to solve. See, most of you must be remembering one thing, that whenever like log things are involved, we consider the log table. But it's not required that every time in the exam they'll be giving you log table. So you should know a way by which you can easily solve the log values. So let me tell you that if you'll be learning the four values, what are those? First one is log 10 is 1. Then you have log 2, log 3 and log 5. If you'll be knowing these values, guys, yes, these three values you can make you solve what, guys? It can make you solve the 95% of the questions, because if you know the identities, and if you also know, if you know these three identities, and if you also know the log 1, like 1, 2, 3 and 5, you can get most of the answer. So log 2 is 0.3010. What is log 5, guys? Log 5 is 0.6989. What is log 5? Log 5 is 0.6989. And I'll write it here again. I guess you must be facing difficulty to relate what it is. So log 5 is 0.6989. And what is log 3? Anyone knows what is the value of log 3? Yes, it is 0.4771. What is that, guys? It is 0.4771. So if all these values you will be knowing, you will be able to do most of the questions in the really easiest manner. You don't have to depend on the log table, guys. You will be able to solve all of them 95%. And the 5% which you won't be able to solve, for that, for sure, the log value will be given to you in the question. So this is what you have to know, that 95% of the questions you will be able to solve with these four log values. If any other log value will be required, yes, that will be given to you in the question, so we can understand. So E cell is equal to E naught cell. Now tell me, guys, here I have log A minus log B, because log is outside, so I can write it as log A minus log B. So log A minus log B, can I write it as log A by B? Yes, guys, can I write it as log A by B? So what I will get the equation? I will get the equation as E cell is equal to E naught cell minus 2.303 RT by NF log concentration of cathode minus concentration of anode. So it is in reciprocal, guys. 1 upon Mn positive cathode divided by 1 upon Mn positive anode. So anode is going to go above, and you will get what? The concentration of anode ion divided by concentration of cathode ion. So this is what we get the equation. Now talking about it, actually, guys, remember that. So this is what we have got the equation, which is E is equal to E naught cell minus 2.303 RT by NF log concentration of anode divided by concentration of cathode. This is there. Now this is actually, guys, the correct equation which we can write is E cell is equal to E naught cell. Above also is correct, but the more correct one is log concentration of products divided by concentration of reactants. In most of the questions in the equations, if I discuss, like suppose you have copper 2 plus zinc, if you will write give Zn2 plus copper. Now what you can relate, if you will write concentration of products, if you will write concentration of product, what you can, zinc is getting oxidized, copper is getting reduced. So this is undergoing oxidation, this is getting reduction. So if you will write products mean you will write Zn2 positive concentration and Cu concentration. So Cu will be 1 only, yes. And for reactants you will write Cu2 plus and Zn will be 1 only. So this is a anode only because it is undergoing oxidation, and Cu2 plus is cathode only. So that way only you get it. So the better way to write this whole equation is, you can write E cell is equal to E naught cell minus 2.303 RT by NF log concentration of products divided by reactants. So that is what we can mention. Clear with it, guys? Now if I say this equation which I have, say E cell is equal to E naught cell minus 2.303 RT by NF log concentration of anode divided by concentration of cathode. That's what I was writing. We have it in the same equation only what we have derived. Now remember that, guys, your R value, is it constant? Is it going to be constant? Yes, T is constant, F is constant. So can't we simplify it and use it in equation which is going to make my calculations easier for the numericals? So what I can write? I can write E cell is equal to E naught cell minus 2.303, R is 8.314, T is 2. Yes, what is the temperature that I consider? So temperature is going to be the fixed value, which is 298 Kelvin, because we will be considering 25 degrees Celsius, divided by N into Faraday 96500 Coulomb. So you can solve this value. Yes, guys, you can solve this value. So log concentration of anode divided by concentration of cathode. Okay, that's great, Abhishek. I hope you will be getting good score only. So do let me know the score also. So here this I can solve it, right? So everyone, if I can solve this I can just simplify it and solve it and utilize in the equation. Okay, mention not, Abhishek. If in future also you require for any other chapter notes, you can just let me know. So this is there. Now what you can relate, E cell is equal to E naught cell. If we solve it, because obviously in the exam you won't be solving again and again if it's a fixed value, because you just have to put it and solve it. They all have a constant, like you don't have to change it. So you can just solve it, and when you will solve it, you will get 0.059 divided by N log concentration of anode divided by concentration of cathode. So this is my Nernst equation which I can utilize in any of the numericals, in any of the question. Correct, everyone? So this is our Nernst equation. Clear with it, everyone? Now this is a simplified equation. Whenever you have to do the numericals, you can utilize in it, and you will be able to get the you will be able to get the answer if you will be putting all the terms correctly, and that's what we can understand. Now let's just discuss one more relationship, and then we'll be discussing the numericals related to both of them together. So one more relationship that we have to know is what is the relationship between, yes, Abhishek, Suman. So we'll be discussing one of the relationship which is equilibrium constant for Nernst equation. How we can relate equilibrium constant for Nernst equation. So everyone remember from 11th standard? Okay, Abhishek, I'll be sending that. So equilibrium constant, actually, Abhishek, on my Telegram channel I have shared one OneNote link, and in that OneNote link every chapter's notes is there. I think you have joined Telegram late, so that's why you are not able to access it. So my handwritten notes in the respective batches I have provided as a OneNote link. So that is like a notebook only, like how you open the notebook and you have a chapter 1, chapter 2, and like that. So that is a notebook only, and I have only written all those notes so that you can access it. So what I will do is I will share the notes link again. So in that all the chapters are there. Okay, so in that everything is written in so simplified manner. If you will go through it now, if you just go through those notes only, and one of the very good thing for you, because you are a CBSE student, so I have mentioned CBSE questions only in that, like NCRT questions are there. Most of the questions are NCRT questions itself, so you will be able to access it. I'll be sharing that. So equilibrium constant for Nernst, yes, equilibrium constant for Nernst equation, how we can find it out. So I hope you guys remember from the class 11th what is equilibrium constant. So you remember that equilibrium constant is nothing but, like, suppose if you have any of the given equation, say A plus BB gives CC plus DD. What are ABCD? ABCD are the stoichiometric coefficients over here in the equation. Now how you can write the equilibrium constant for any reaction? It's very simple. Concentration of products raised to power of their stoichiometric coefficients, D to the power D, A to the power A, and B to the power B. Yes, so what you can understand here is simple. How we used to write the equilibrium constant, that is nothing but concentration of products divided by concentration of reactants. Products divided by concentration of reactants. Now you should know that this is QC, but this is QC is like equilibrium constant, which we define specifically at equilibrium condition. This is equilibrium constant, and this we define at equilibrium. But till the time reaction is not yes, till the time reaction is, yes, tell me, till the time reaction is not achieved or is not reached to a equilibrium, what you can understand, if it has not reached to a equilibrium, so you can define QC, which is the same thing, concentration of products divided by concentration of reactants. So QC is the reaction quotient, which is nothing but the concentration of products only, concentration of products divided by concentration of reactant. This is at any point other than equilibrium. So in a reaction, at any point other than the equilibrium, you can define reaction quotient. Concentration of products divided by concentration of reactants. Very good. So at equilibrium, guys, remember. How many of you guys remember? Suman, Abhishek, everyone. Yes. Rajesh, Veena, yes, everyone. So at equilibrium, you have to know QC is equal to KC. Means your reaction quotient becomes equal to KC. So what we can relate, because your E cell is equal to E naught cell minus, we wrote the equation, E cell is equal to E naught cell minus, yes, E cell is equal to E naught cell minus 2.303 RT. Like if I relate the exact equations, it was 2.303 RT by NF log concentration of anode divided by concentration of cathode, which we can write as concentration of product divided by concentration of reactant. So we can write it as log QC, and at equilibrium we can write, instead of QC, we can write it as KC. So yes, the relationship which we can get over here is, yeah, between KC, that is equilibrium constant, and E cell is equal to E naught cell minus 2.303 RT by NF log KC. Correct? Very good. Now what we can understand here, that at equilibrium, always remember that NF, this is N, it's not going to be always 2. N is not always going to be 2. N is depending upon the reaction, number of electrons involved. The before example that we discussed for copper and zinc, in that N was 2. But in every other reaction, what we can understand, depending upon reaction, we can get a different value of N. So that's why we are keeping it as N only. Now, we should know one more thing, that at equilibrium, your cell potential is equal to 0. Because at equilibrium, rate of forward reaction becomes equal to rate of backward reaction. And that's why at equilibrium, E cell is equal to 0. So if E cell is equal to 0, can I put that in the reaction? Which we learned, E cell is equal to E naught cell minus 2.303 RT by NF log Kc. So I can put E cell as 0, which is equal to E naught cell minus 2.303 RT by NF log Kc. Now what we can understand here, we can get a simplified version. We can get that if we'll be taking this whole thing, because we solved also this, but what we got the value. So we have this. Why I have written that? Because this equation can be utilized in some other relationship as well. So we can mention this equation, like I can mention this, that E cell is equal to, so E naught cell is equal to 2.303 RT by NF log Kc. So this we have understood. This whole equation, if I take it, will become positive. So I have mentioned that. Now it's very simple, guys. If E naught cell is equal to this, I know one thing, that the 2.303 RT and F, it's a constant value. So if it's a constant value, I can utilize that, like which we have calculated before also in the Nernst equation. I can mention that. So I can mention this as equation 2. Okay, and what we can relate is, we can talk about E naught cell is equal to, yes, but before that, let me tell you, I'll be telling you the offer later, but let me just quickly tell that E naught cell will be equal to what? 0.059 divided by N log Kc. Okay, so that's what we can mention. Now can I get what will be the value of log Kc? So I can make this N to be into E naught cell divided by 0.059. So this I can consider as equation 3. So this is log Kc is equal to N into E naught cell divided by 0.059. Yes, this is the relationship that I have got. Now remember, if you have to calculate only Kc in the reaction, this is, we are having log Kc. So remember, if you have suppose log x, right, if you have something like log x is equal to 5, so your log x is equal to 5. So you can find out the value of x by putting nt log to the 5. And nt log, how you can calculate? You can calculate very simple by taking the value which is here on the power of 10. So nt log you can easily calculate by keeping whatever thing you have to calculate, like nt log 5, nt log 7, nt log anything. You can keep that in the 10 to the power and you will be able to calculate. So it's a very simple thing, guys. Like suppose I can mention as a number any other thing also, like log x is equal to k, some value. So you can write x is equal to nt log k and 10 to the power k. So that way you can calculate, if you just have to calculate the equilibrium constant. Very good. This we have understood. So this is my equation 3. This is also telling us the relationship between the E naught cell and Kc, equilibrium constant. We'll be learning one more relation before also talking about the numerical. So there is one more relation, guys. What is that? Electrochemical cell and Gibbs free energy. What is that? Electrochemical cell and Gibbs free energy. So electrochemical cell and Gibbs free energy, what we can understand here, it's very simple, guys. Yes, electrochemical cell and Gibbs free energy, what we can understand, how we can get to know the relationship between them. So you can relate that the Gibbs free energy is delta G. The formula for that is NFE cell. How this is how Gibbs free energy is related. Gibbs free energy is what, guys? The energy required to do the useful work for the system. The energy required to do the useful work for the system. So that is Gibbs free energy. And the relationship between Gibbs free energy and the cell potential is this: delta G is equal to minus NF E cell. If I'll be talking about standard Gibbs free energy, I can write it as minus NF E naught cell. So delta G naught is equal to minus NF E naught cell. Very good. So if I know that this is a relationship, so I can write delta G is equal to minus NF. Now E naught cell, you remember the equation that we learned, the equation 2? Yes. So the equation 2 we mentioned E naught cell is 2.303 RT by NF log Kc. That's why we took this as 2.303 RT by NF only, guys, because we can learn that in the other equations. So what we can understand, I can use the E naught cell. So using equation 2, what I can do, delta G naught is equal to minus NF into 2.303 RT by NF. Yes. So NF and NF will get cancelled and you will be having RT log Kc. So this is the relationship between Gibbs free energy. Yes, it is delta G is Gibbs free energy. So delta G is equal to minus 2.303 RT log Kc. So this is the relationship between, your Gibbs free energy and Kc, that is equilibrium constant, and this is what we can relate and understand. It's very simple. So today we have learned 3 formulas along with their derivations. What are those? So the first thing we learned is a Nernst equation for E cell. So Nernst equation for E cell is what? Your E cell is equal to E naught cell minus 0.059 by N log concentration of products divided by concentration of reactants. We mentioned that you can mention it as log concentration of anode divided by concentration of cathode as well. So what I can do, I can mention it as E cell is equal to E naught cell minus 0.059 by N log concentration of anode divided by concentration of cathode. So I can mention that. This is the first equation. 3 main important formula. Yes, exactly. So these are the 3 main important formula. First is Nernst equation. Now second is the relationship between, second is relationship between E cell. So relationship between what? Between your electrode cell potential and your equilibrium constant. So relationship between Kc and cell potential. So what is the relationship that we have got? We have got very simple. So standard cell potential we are talking about. So it is log Kc is equal to E naught cell into N divided by 0.059, or you can mention this as well, that E naught cell is equal to, E naught cell is equal to 0.059 N, 0.059 divided by N log Kc. So anything you can mention. So this is the second formula, relationship between Kc and standard cell potential. Now let's just talk about the third formula which we have related, that is the Gibbs free energy and standard cell potential. Gibbs free energy and Kc, the relationship. So it is very simple. Delta G naught is equal to minus 2.303 RT log Kc. So that is 2.303 RT log Kc. This is the third formula. So these are the 3 formulas which we have learned, that how we get it and how we can utilize it. Okay. So let's just discuss one question related to it, guys. Let's see who and all will be able to do it. And it's going to be very important for us to discuss a formula, like all the formulas. So we have discussed it. Now let's just discuss few questions related to it, and let's see who and all will be able to do it. So the first question that we have is, the question is this one. Yes, correct. Very good, Abhishek. So let's just do one question related to Nernst equation and how we'll be doing it. Let's just see that. So the question is calculate. So we have a cell. So this is one of the example from the NCERT only. What this question is saying, represent the cell in which following. Yes, for the cell, calculate E cell. Question is for the given cell, calculate E cell and also represent it. So represent it as in, if you remember that, so we can write this question in one more language as well, so you will be able to relate it better. So represent the cell in which following reaction takes place and also calculate E cell for it. What we can mention, so this is represent the cell in which the following reaction takes place. In which the following reaction takes place, and the reaction is magnesium solid plus 2 Ag positive. Concentration they have given Mg2 positive. Yes, for that also they have given 0.1030 molar plus 2 Ag. So for this reaction, represent the cell in which the following reaction takes place, calculate its E cell. If E naught cell is equal to 3.17 volts, if E naught cell is 3.17 volt. So this is given. Now everyone has to try to solve this question and see whether you are able to do it or not. Everyone should try it, guys. Okay, so how we represent the cell, guys? You remember all of you ABC? Yes, so we do the representation of cell as ABC. What is ABC? ABC is anode, bridge and cathode. Okay, that's great, Abhishek. So ABC, how we can write? So we can write first anode, who is acting as anode, who is undergoing oxidation. So magnesium is getting oxidized, so this is undergoing oxidation. Silver is getting reduced, so this is undergoing reduction. So what we can relate? We can write what is anode. Anode is nothing but Mg. Yes, Mg. Then it is getting converted into Mg2 positive. We can write that. So you write metal, then it's iron, yes, whose concentration is given 0.130 molar. Then you can write a salt bridge and you can mention Ag positive, which is 0.0001 molar, and you have Ag. So this is your anode, this is bridge, and this is cathode. This is how we can mention it. Now, how we can relate? We know that E cell is equal to concentration of anode, like E cell is equal to E naught cell minus, yes, minus, we were having what, guys? 0.059, yes, 0.059 divided by N, log concentration of products divided by concentration of reactants. Why I have mentioned that, guys? Because anytime, this is a very important thing to know over here, if any time in any reaction, if they have given you, yes, if any time in any reaction they have given you a stoichiometric coefficient, so whenever you will be mentioning that ion, you have to take that stoichiometric coefficient in the power, the same way we do for the equilibrium constant. So what I'll be mentioning here, concentration of products divided by reactants, or concentration of anode divided by cathode. So my cathode here is silver, who has a 2 stoichiometric coefficient. So this 2 will come in the power when I'll be mentioning the reactant, like when we'll be mentioning the concentration. So that's what is the important part over here. Rest of the things are simple. So my formula is E cell is equal to E naught cell minus 0.059 divided by N log Yes, concentration of anode divided by concentration of cathode I can mention. Now here it's a simple thing. Number of electrons are how many involved. So you can relate that magnesium is losing 2 electron and that same 2 electrons Ag is gaining it, and it is forming the silver metal. So what we can understand here, the total number of electrons involved over here is 2. Very good. The number of electrons involved is 2. And concentration of anode and cathode, how I can write it, I can just put the values. So E cell will be equal to E naught cell, which is 3.17 minus 0.059 divided by 2 log concentration of anode is 0.130 divided by 0.001 square. Okay, now how you can solve it, guys, let me tell you that, because here this value you can solve it, but here you how you'll be solving it. So you have a log 0.130 divided by 0.0001 into, you can write 0.0001. So you can remove this points and you can get over here 10 to the power 6. 10 to the power 6 or 8? 10 to the power 8. So if you'll be removing those points, you will get 10 to the power 8 over here. You can remove even these 3 points also over here. So you'll be left with 10 to the power 5. Now you are left with log 130. Yes, log 130 divided by 1 into 10 to the power 5. So you can make it as 13.0 and you can make it as 10 to the power 4 as well. And now what you have to know, log 13 obviously you cannot solve with the help of it, but yes, what we can understand is very simple. You log 13, if you will be getting, you will be getting that value in the question itself. But if it is some other log, like suppose if you are having log 8 and you have to calculate the value, so how you can calculate it, you can write it as log 2 to the power 3. Good evening, lovely. So log 8, suppose you have to calculate, you can write it as log 2 to the power 3. Log 2 value you know and you can calculate. Suppose you have to calculate log 15. Log 15 you can write it as log 3 into log 5. So you know log 3, you know log 5, you can calculate it like that. So I told you that you have to learn log 2, 3, 5 and 1, and you can actually calculate any of the values from it and you can easily get it. Okay guys, I hope everyone is clear with it. You want to do one more question, guys? Yes, tell me. So let's just do one more question, which is easy only. Let's see who and all will be getting the answer. So they are saying the standard electrode potential. So the E naught cell for Daniel cell is given 1.1 volt. Calculate the standard Gibbs free energy. Energy for the cell. For the cell which is Zn plus Cu2 positive gives Zn2 positive plus Cu. So they are saying E naught cell is given. Calculate the standard Gibbs free energy for the cell, which is Daniel cell only. Zn plus Cu2 positive gives Zn2 positive plus Cu. So everyone should try to do it and tell me what do you think how we can do it. It's a simple thing. Yeah, CBSE if required in the exam, that's what they said, right? So sometimes when you have a log 8, log 15, like these kind of values, actually they are not mentioned. So they'll be giving you the log values when it is required, means the one which you cannot calculate even with the help of this like basic values, right? So yeah, like CBSE mostly will be providing it, but for competitive exam for sure it is required for you to know log 3, log 5, log 2, all these values for sure are required. Okay, so E naught cell we can calculate it. So here guys, what formula will be using it, tell me. It's very simple. Delta G is equal to, I have to calculate delta G naught. Yes, and what they have given me E naught cell. So delta G is equal to minus NF E naught cell, correct? This is a formula, no? So E naught cell is given. Number of electrons involved over here is how much, guys? It is 2. Very good. The number of electron involved is here 2, and Faraday constant we know only, so we can calculate that. Correct, guys? So delta G naught will be equal to minus 2 into 1.1 into 96500, and you can solve it and you can get that. Clear with it, everyone? Yes, so you will get around 212 kilojoule per mole. You can get the value of the Gibbs free energy. So this is what we have related. We have understood about the Nernst equation. We have understood today about the equilibrium constant. For the Nernst equation, how you can calculate what is the relationship between Gibbs free energy and your electrode potential, that also we have understood. Very good. So that's what we have done. Make sure you guys are revising it. If you get any doubt, do let me know in the next session. So let me just quickly inform you about few of the things, guys. So the first thing is, yes, again I'm telling that because today is the second last day for the offer. If you'll be using MRIS10, which is my code, you are eligible for getting up to 41% off. If you use, like if you take a 24-month subscription, you will get 6-month subscription absolutely free, and you will be able to do the 41% around. Yes, it is going to give you the discount. So make sure you are availing this offer. Thank you, Abhishek. That's actually very good to hear, because if this is how, like this is why we teachers are, to make the subject, to make the things easier for the students. So thank you so much for saying it. Now talking about the upcoming batches which are coming for class 11 and 12. So for class 12, IC class 12, the batch which is going to come. Yes, okay, thank you, Abhishek, thank you so much. Now achievers batch which is there for ISC class 12, guys. Yes, it is going to start from August 4. I'm taking the chemistry classes. Again, I'm telling biology is taken by Lakshya Gera sir, physics classes are taken by Mohana Thara ma'am, and maths is taken by Rahul Mohnani sir. Same teachers are there for IC class 11 also, guys, and a new batch is starting from August 4. Now let me introduce you about our community. So the community is there on our Unacademy app, and if you will be a part of Unacademy, you will never miss any update from your favorite educator. You will be getting the session notes and practice material, and you can share your feedback directly with the educators via codes. So this is a really good thing, and this is what we have done today, guys. So make sure you're revising all the things that we have studied today, and we'll be meeting in the next session. So yes, guys, make sure those who are new on the platforms, you are subscribing the channel, you are pressing the bell icon, so that you will be getting a notification whenever there will be a session. So okay, guys, I'll be coming on the 1st August only, Abhishek. So you can just press the bell icon, you will be getting all the notification regarding the classes. So for August, it will be showing very soon. Okay, so most probably I'll be there live on Monday. So okay, guys, we'll be meeting in the next session then. Thank you all of you. Bye bye, guys. Thank you everyone. Bye. Thank you everyone.